Hello, everyone. Welcome. We're going to make a quick start as we'd like to make the full use of the 35 minutes that we have. Firstly, just wanted to say a huge thank you for joining us today at KubeCon. You might have had a busy week and you might be tired and or hungover, so thanks for making it to our talk this afternoon. So back in the 80s, Van Halen was a powerhouse of rock and roll who were known for their extravagant performances, but they also garnered a reputation for something a little bit more interesting, and that was a peculiar backstage request. Now, upon first hearing, you might think that it's simply rock star diva-ish behavior, but there was, in fact, method to their madness. So I have a little prop at the front. So I'm going to throw these into the audience. They're boxes of M&Ms. And their request was that in their dressing room, they wanted to have a bowl of M&Ms with the very strict caveat that there could be no brown M&Ms. I apologize, there are brown M&Ms in your packets. Now, you might be wondering why they did this, because I've said that there is method to their madness. And what they realized was if the crew looking after them delivered on a bowl of M&Ms, it was a great indicator that they had read the contract in detail. And as platform engineers, we also need to be careful about the detail. In a world of distributed systems and cloud platforms, a lack of configuration or a misbehaving app can create lots of troubles for you downstream, which could ultimately lead to reputational damage or financial loss. So as platform engineers, we must be guardians of the detail, or as we're calling it today, the brown M&Ms of platform engineering. So a key requirement for an internal developer platform is that they serve multiple workloads. And to achieve platform engineering, we'd like to talk to you today about micro-segmentation and multi-tenancy. The reality of platform engineering is that while it seeks to lower the barrier to entry for building your applications, it also needs to balance cost with an appropriate level of security. And it's therefore essential to consider how different application components running on shared infrastructure, that's key, are allowed to communicate with one another, and then weigh up the cost of the architecture that you've chosen. We've seen quite a few differing approaches to deploying Kubernetes, all the way from multiple single-tenant clusters through to namespaces-as-a-service, and we're going to touch on both of these today. Have the lovely Jim with me, who will introduce himself in a moment, who's going to give us a live demo of two products in the open source community that you probably have heard of, or hopefully have heard of, that will allow you to do both micro-segmentation and multi-tenancy for yourself. So quick introductions. My name is Rachael Wonnacott. I'm very proud to be the Associate Director for Container Platform Engineering at Fidelity International. I was a software engineer for 10 years. I missed the hands-on a little bit, but I'm really enjoying getting to make those big picture, holistic architecture decisions and have greater impact on the organization. Over to Jim.
Hi, everyone. I'm Jim Bugwadia, co-founder, CEO at Nirmata, also a Kyverno maintainer. So our mission at Nirmata is to automate security and provide the right guardrails and control. And we'll talk about some of that in terms of what we can do for platform engineering.
So it's quite a simple one. I'm going to talk to you about platform engineering, my favorite topic of the year. It is in the hype cycle. Then we're going to talk to you about the brown M&Ms, multi-tenancy, and micro-segmentation, and why that's important for platform engineering. And then the wonderful Jim is going to do all the hard work and do a live demo, which we hope works, using Kyverno and Cilium. And at the end, we will have some time for Q&A. So platform engineering, we have given it a name, but it has arguably been in the ecosystem for quite some time. Huge organizations, your Facebooks, your Googles, Netflix, Airbnb, whomever, had their internal developer platforms all the way back in 2010. Now, the name platform engineering seems to have garnered popularity around 2018 when Evan Bottcher wrote What I Talk About When I Talk About Platforms. And he described a digital platform as a foundation of self-service APIs, tools, services, knowledge and support, which are arranged as a compelling internal product. Autonomous delivery teams use this platform to deliver product features more quickly, but perhaps more crucially, with reduced coordination. And so it probably makes sense that when we talk about platform engineering, we're typically talking about reducing the cognitive load for the developer. And this term, cognitive load, was popularized in 2019 by the book Team Topologies, when they described a platform team as building and delivering internal services to reduce the cognitive load for those application workload teams if they'd had to build those services for themselves, while, and this is important, still leaving the responsibility of building, maintaining, and fixing those applications in production. So what are the challenges here? There are a growing number of things in the ecosystem, and that means a developer has to think more and more about more and more things when they want to build their application. So the cognitive load here is very high. There are new services coming online all of the time, and no individual can simply know everything. Microservice architectures can become increasingly complex, particularly if you work in a large-scale organization. And even with the best of design intentions, software generally tends to suffer from what we know as architectural sprawl. And even with one's own company, it can be quite difficult to know whom to talk to. If you work in a large organization, there are so many people you might need to chat to, and you might encounter a variety of disparate onboarding processes, which, if you need to use a variety of services and tools, can make your job quite complicated. Additionally, many organizations, and I'll confess, typically the enterprises, are running in the hybrid model. And this can be down to a variety of reasons, be that maturity, security appetite, or perhaps regulatory constraints. And the challenge with running in the hybrid model is that it can often make complexity at the network layer, or worse, if you have an overly distributed system, which I have seen in industry, leads to latency, which if you're international like we are, can be quite a large problem. Security threats are increasing both in sophistication and in number, and as your system becomes more complex, it's actually far more challenging to design for security, but also then to articulate your design to auditors who perhaps aren't super technical themselves. Sorry to any auditors in the audience. And if you work in a financial institution, you're probably going to find that those regulations are extremely rigid. Finally, if you've worked in a business, then you'll know that you have lots of different application teams doing lots of different things. And if everyone is doing something slightly different, that means you need a slightly different bit of evidence for audit, and that becomes quite quickly unmanageable. Is this video going to work? Let's see. No, it's not. Imagine a really lovely GIF of a cookie cutter here. So platforms are a great way to bake in standardization, if you will pardon the pun. And it's therefore a great way of demonstrating the expected behavior of each of your workloads. Any features that are common to all of your applications, you can embed in at the platform layer, which, for enforcing security best practices followed, is really quite handy. Standardization. So by standardizing the way that workload teams interact or use your platform, you can reduce the amount of unique configuration, which is great. This is much easier to maintain and far simpler to evidence to those lovely auditors that I've mentioned already. This in turn reduces the cognitive load, bingo, tick that off, for your workload teams and for your leaders alike, because they only need to understand one pattern, or perhaps a few set patterns to get going. This has the added benefit for career vitality of making it far simpler to move people within your organization from team to team. And in the same way, if you operate with similar working practices from a set runbook of architectural principles, it's far quicker to onboard a new engineer to any part of your organization. The less variation there is, the quicker and the simpler, hopefully, that you can test and analyze any rollouts that you want to give to all of your platform. And for security, that means that you can do things like patching vulnerabilities and making bug fixes far quicker. And as anyone who's worked in a business will know, you simply can't escape cost analysis, and the benefit of standardization is a much simpler chargeback model, which allows for much more predictable spend. Platform MVPs. When a lot of people think about platforms, particularly if that person is not very technical, or if that person hasn't worked in platform engineering before, or has maybe never written a line of code, it's really easy to become enamored with the visualization of portals. And while I recognize that portals are fantastic and they have loads of value to add, I really do believe that the value of a platform comes from its orchestration. A portal is just a portal. What the portal is actually doing is magnifying or amplifying access to that orchestration. And so when you think about running running infrastructure and achieving orchestration, you need to think about the raw fundamentals of running infrastructure. And for me, that's typically the network and security. So I'd like to caveat that while we definitely recognize that authentication and authorization are essential for multi-tenancy, given the time we have with you today, it's out of scope for our demo, and we're going to focus on isolation at the network layer. Let's get a bit more Kubernetes specific. We are at KubeCon after all. So Kubernetes clusters are typically used by multiple teams within an organization. And in other cases, they are used to deliver applications to end users. In either case, you probably want to have multi-tenancy or some kind of segregation, particularly if you want to divide resources among differing people from different organizations. Secure sharing of the Kubernetes control plane and of the workloads both allows maximal productivity, but also helps with security in both cases. And how do you do that? The brown M&Ms of platform engineering, multi-tenancy and micro-segmentation. The simplest way of describing running multiple workloads in a single platform is multi-tenancy. The clue is kind of in the name. And that typically is going to require some kind of segregation at the network layer to isolate your workloads. Micro-segmentation is simply one or two layers deeper, where you're dividing a larger network into smaller subnetworks, or segments, if you will, and to limit the access and improve security. What you're able to offer here is more granular control over different aspects of your workload, be that to have different development environments or perhaps different application tiers, just by further segmenting workloads into smaller, isolated networks. Okay, so in industry, we've seen multiple approaches to multi-tenancy, and there isn't really time to go through all of them today. So if you do want to go into more detail, there's a really lovely blog here that Jim contributed to that we've linked. Please take a look at that. The first one that we see is typically cluster as a service, and that's where you have a single tenant per cluster. And this is nice because the model allows tenants to have different versions of cluster-wide resources, such as CRDs, and provides full isolation of your Kubernetes control plane. Next up, we have namespaces-as-a-service, and hopefully that's in the name as well. Tenants here are sharing a cluster, but workloads will be restricted to a set number of namespaces. The control plane resources, like the API server and the scheduler, but also the worker node resources like CPU and memory, are shared among all of your tenants. And finally, one that we're seeing sort of gain popularity recently is the control plane as a service, which is kind of another level of cluster as a service. This case, it's virtual. So the tenant cluster has a virtual Kubernetes cluster, where each tenant gets their own dedicated Kubernetes control plane, but will share the wider node resources. As with any other form of virtualization, there shouldn't be any experience difference for that customer between using a regular Kubernetes cluster or the virtual one. So Fidelity is doing namespace as a service, so this is where we get slightly into the use case. And a big driver for us adopting Kubernetes was that we wanted to reduce cognitive load for the developers, but we also wanted to reduce risk to the business. And we decided quite early on that we wanted to do that via standardization. And we felt that namespace as a service was a clean, nice way of managing our configuration to do this. It's quite a simple way to isolate your development environments. We don't mandate how many teams can have. They can have as many namespaces as they like. It's the right permission boundary for role-based access control. It's quite easy to create application tiering, which we're going to touch on within a workspace, and there's standardized and predictable cost of centralized services. I'll admit that Fidelity was a little bit late to the table with Kubernetes, but this has the advantage that we can learn from the community. Ongoing operational costs for management and maintenance of a cluster can be really difficult to predict from the onset. And what we've seen in the community with increased Kubernetes adoption is that enterprises, which we are, often experience what is known as cluster sprawl. And typically, this is a rapidly growing number of single tenant clusters that are lacking centralized governance. So we didn't want to do this. Cluster sprawl exacerbates management complexity, increases your operational overhead, and it kind of adds other costs that you might not have had any way of predicting, which we wanted to avoid. So a careful application of a multi-tenant strategy, in this case, namespace-as-a-service, was our way of trying to mitigate cluster sprawl. So finally, we've mentioned already that micro-segmentation can be used to achieve application tiering. And if you, haven't clicked on, 1 second. There we go. And if you look on screen, I've given you the most simple example you could possibly have. There's only 2 tiers. That's largely for the expedience of the demo in a conference environment. So this is the layout of the guestbook application that you're going to see. And in simplest terms, we have the visualization of the app in the front end, and perhaps you have something like a database in the back end. And for us, this is going to be as simple as dividing the network into 2 subnetworks or segments. And we can do this to enforce security checks using policy to prevent any unauthorized movement between the workloads. So we've deliberately kept this example really simple just for the expedience of the demo. And now I'm going to hand over to Jim, who gets to do all the hard work.
Thank you, Rachel. All right, so for the demo, there's 2 requirements we want to implement. The first thing we want to do is to make sure we have secure self-service multi-tenancy, which in this case is namespaces grouped together as a workspace. And then the next thing we're going to do is within these workspaces itself, show how to do segmentation further with policies as well. The 2 projects we're going to use are Cilium and Kyverno. And most of you may have heard of them, but for those who have not, Cilium is a CNI plus a lot of other tools for observability, security, also for tracing, metrics, et cetera, on the networking side. Very widely used, also part of now the Kubernetes security certification, so definitely a good tool to know. Kyverno is a policy engine which was initially created for Kubernetes, but since then has been also made available outside of Kubernetes. It can mutate, validate, generate, as well as clean up resources in clusters, and can verify images within your pipeline or in clusters. So with those 2 tools, both of them offer policies, right? And one question we often get is, what's the difference? Why do I need policies both in Cilium as well as Kyverno? So really the way to think about it is Cilium is providing the firewall rules or the network policies, which will control what traffic can flow in and out of your applications, whereas Kyverno is providing the guardrails for Cilium policies, for the traffic rules, as well as automation of those. So when you're building a platform, that standardization and automation becomes really important, and you can do things like, is this policy really something that should be allowed within this workspace? So what we're going to do, like Rachel already introduced to us, is we're going to use an application with 2 simple tiers. We'll use application segmentation within those with the standard guestbook example. And then we'll also look at how this extends if you have multiple workspaces and are using these. So to implement this, there's a few different policies we're going to see, Kyverno policies in action. The first is labeling. Just like with cloud resources, proper labeling is required for management, for scalability, et cetera. So we're going to make sure every namespace has a workspace label as well as a tier label. And the tiers are just front end and back end in this case. We're also going to automatically inject labels into pods as they run. So this is not something you want to delegate to your developers. You want to automate this as much as possible within your cluster. And this is a good example of a Kyverno policy to do that. We'll also automate generating default traffic rules for things like DNS, as well as traffic within namespaces or within workspaces. Workspaces just, again, being collections of namespaces. And then finally, we want to put some checks in place to restrict what can be done in different tiers and what type of traffic is allowed from various tiers itself. So let's dive into the actual command line demo and see what that looks like. So here, already on my screen, as you can see, I have, I'm using a cluster, and I had already run the Cilium command. So Cilium's installed here, and let's just make sure the right namespaces are there. So we see that Kyverno is also installed. So if you look inside of that namespace, what we should be able to see is there's 4 controllers. The admission controllers Kyverno runs, background controllers for applying mutate and generate policies, as well as controllers to clean up and report on resources. If I look at my cluster policies, I have the policies I just described earlier installed already and ready to go. So we'll start with a very simple example. I'm going to create a namespace called test. And that gets rejected because I don't have the proper labels, right? So we want to make sure that, no matter how you're creating your namespaces, whether it's through a portal or whether it's on the command line, you have that enforcement. So let's go ahead and apply a namespace which does have these labels. And what we should see at that point is that namespace is allowed. And if we look inside of this namespace, I want to see what cluster policies are already created for me. And what Kyverno did in this case is it watched for the creation of the namespace and automatically created a deny all policy through a generate rule, which denies all traffic within that namespace. Now, as the owner of that namespace, let's say I want to allow DNS traffic, what I would do either, again, through GitOps tools or through other tooling that I want, or if I have access to the command line, I would need to add on a pre-agreed to label. In this case, it's allowed DNS traffic, which should have created another network policy which allows DNS. So again, you can now, in a fine-grained manner, offer developers the self-service they need for certain allowed primitives, but also restrict other things in this namespace. Now, one thing I can share, like if we look at this namespace and if we edit it again, you'll see it's labeled with the backend tier. And this is the tier where you want your databases, et cetera, to run. So let's say if we want to run Nginx in this tier, or actually in this case, although the pod's called Nginx, let's change that. We want to run Redis in this tier and see that it inherits the labels for the tier itself. So here what I did is I just did a dry run on that, and I'm looking for these two labels. And as you can see, Kyverno is monitoring that and automatically injected the necessary labels. But if I try to run an actual Nginx image, I would expect that not to be allowed in this case because I don't want to run arbitrary images in my data tier. I only want to run some trusted images in here. So in this case, Kyverno blocked that, and it failed this image from being run in here. So one last thing to check in this namespace is if I apply a network policy. So in this case, I have a policy which allows, it's a Cilium policy, which allows the access or egress traffic to the internet or to the world from here. And obviously, you don't want that to happen in your data tier, because the first thing any malicious user or an attacker would do is they're going to try and reach some external source. So you want to block and prevent some of these just based on simple labels or tiers. So now that we have done some of these basic tests, and we know that our policies are working, and by the way, with Kyverno, you can automate all these tests in your CI pipelines. So for true policy as code, it's a best practice. We also have another sub-project called Kyverno Chainsaw, which helps you, do some of these tests and checks for behaviors. So definitely recommend taking that approach. But let's go to a more complex example where we actually run a guestbook, right? So I'm going to run 2 instances of guestbook. And here we're seeing this particular chart. I'm going to label it with workspace 1. And I'm also going to install this again, and we'll call it workspace, or we'll label it with workspace 2. So now, well, it seems like that one is already in use. So let's go ahead and we can give it a slightly different label here, workspace 3, and see how that works. Oh, there we go. So I think we need to change this to make it work correctly. So now we know the demo is actually live, so there we go. All right, so now we have 2 instances of guestbook running. And what we also, in a subtle manner, enforced in our by using these tiers is we're only allowing 1 application tier per namespace, which is also a good best practice, using namespace isolation, segmentation, and making sure now we can have the proper RBAC controls, other controls on that namespace itself. But now that we have this running, the other thing we want to do is, if we look inside of, let's take the guest book, the front-end application, within the first workspace. So let's get the pods running in here. And here we're going to run a debug container, and I'm going to run a utility called netshoot, which installs a number of different networking debug tools, which are very useful. And we'll see the connectivity checks we can get from there. So if I run this, it will attach to the container. It runs netshoot. And now what I want to do is I want to be able to reach out from this particular pod, which is the front-end pod within the first workspace. And I want to test connectivity to the back-end pod, which is Redis, in that same workspace. And remember, these are in 2 different namespaces. Each namespace completely isolates its traffic, but we want to make sure there's connectivity within the workspace itself. So that works. And then the next thing to check is to make sure that if you have 2 workspaces running the same application, I'm not able to connect from the front-end application for the first namespace into the back-end application, Redis, for the second workspace here. So let's go ahead and try that. And what we're expecting to happen is that fails, right? So it timed out because there was no connectivity there. So this shows that there's full isolation across workspaces. There's isolation also in namespaces, but it's very easy to extend. And the way this happened, if I go back and also look at my cluster level, what happened is Kyverno automatically generated cluster level policies for the workspace networking itself. So this shows, with a few policies, so literally about 6 policies, and Cilium itself, we were able to automate quite a few different traffic rules, standardize on different tiers, and provide self-service to developers. So if there's additional Cilium policies, things like that they want to run, they can do that themselves in here. So with that, I'll hand back to Rachel, who's going to conclude the session.
Thanks very much. Okay, so just a little quick summary, really, of what we've spoken about today. So hopefully you can see that platforms ultimately enable agility via standardization. And while standardization might sound boring, we're humans, we love to be unique. We like to think of ourselves as different. There's actually so much business value to everyone doing things in the same way from a speed perspective. And typically, if you can abstract away things like security and the network in a standardized manner, it allows you to be unique in your applications. Let your business, whatever it is, shine through applications, but keep your infrastructure boring. Multi-tenancy and micro-segmentation are essential building blocks in Kubernetes for platforms. Hopefully, we've convinced you of such. And 2 of the tools that we use at Fidelity that I'm a huge fan of are Cilium and Kyverno, and they provide a powerful combination together for delivering secure self-service. Thank you so much for being with us today. We have time for questions, I believe. Yes, we have time on the clock. Lovely. Running to schedule is always good. So if anyone has any questions, there are 2 microphones in the middle, and we'd love to chat to you.
Great. The demo was wonderful. It seemed very magical. I'm a little curious how much underlying stuff went into those policies.
So there's a Git repo we'll share, so you can take a look for yourself. It's not too much.
Great talk, great demo. I have a question about a comment that was made, how you said you're a little bit late to the game on the whole Kubernetes thing, but that let you learn from the community. If you were even later to the game and today you had to do this all over again, would you choose namespace as a service, or would you go something like virtual cluster, or is it just not ready yet, virtual clusters, in your opinion?
So I'll give you a 2-tiered answer, and I'll provide a bit of context as to why there's 2 tiers. So we started our platform engineering journey back in 2012, but we were running Cloud Foundry on premises. This worked really nicely and was really popular with our developers, but if you're familiar with Cloud Foundry, it was very opinionated, and it didn't really handle data-intensive applications. But there are still people on it that we're trying to migrate. So the context there is that we have some people that want opinionated standardized platforms. I'm a huge advocate for DevOps. I often get the feedback that I may be a bit purist. So I should also caveat that within the organization, we do encourage teams to do their own thing in the traditional DevOps way, either within our AWS platform, within Azure. So not everything is standardized. We recognize a fork in the road, and teams can choose. Would I still choose namespace as a service? Yes, with the caveat that the platform that I'm referring to is built specifically for business application workloads. We are building a second cluster for infrastructure workloads where I'm leaning towards thinking that something like a control plane as a service will be more appropriate. The reasons for that is the business workloads typically are quite simple, so it's much easier to standardize because you can pick out those common features and patterns. For infrastructure, they typically need much more permissive access to things like the internet, which in a heavily regulated industry that operates out of 35 countries can cause problems for things like data sovereignty. So by having the virtual cluster and giving each tenant a dedicated Kubernetes control plane, I think we can navigate some of those challenges.
Hi, thank you. One of the issues I have with multi-tenancy at my org is security wants to see egress traffic from the cluster more segmented, but it all sort of originates from the same CIDR block. So we've been sort of going back and forth between clusters per team so we can have that sort of visibility. Any tips for that? We do run Cilium, if that helps.
Yeah, not fully familiar with this, but with egress gateways, maybe there is a solution where you can kind of use a virtual IP or the same CIDR block across all your gateways. That's probably what I would look into, but it's an interesting use case for.
So I can perhaps take this. So we sort of have two use cases. So there's the original MVP where we wanted everyone to stay within the cluster. So we weren't actually accepting internet ingress as an example for that first MVP. But particularly with infrastructure workloads that need to communicate with third parties or SaaSes or simply with other businesses, we need to start looking at that model. There's a lot that you can do with API gateways. I don't necessarily mean the Kubernetes API gateway. You can pick whatever product you like and spend whatever money you wish on licenses, but there's certainly stuff that you can do by having a single entry point at the outside and then looking at the granularity within the namespace. We found Cilium to be a really flexible CNI that has enabled us to do that. We do that mostly with our network policies, and then to be really sure that everything's working correctly and to appease the auditors, Kyverno has been a really nice way of showing that that is standardized across each namespace.
Hi, I think you mentioned it a little bit at the start when you were talking about how the portal is kind of the shiny part, but it only amplifies the services. I was wondering, do you have a self-service model for developers? And if so, what does it look like?
So we do have a portal. I'm not hating on the portals. It just wasn't really the angle that we were taking with this presentation. I think there's so much value to have from that visualization, particularly from making it a standardized experience for all of our users. So we're actually using Backstage and looking to standardize the experience across all of our platforms. So not just Kubernetes, that will include things like Amazon and Azure as well. Even having a centralized place for documentation so the developer only has to go onto one space is really good. I mentioned in the challenges that you might encounter disparate onboarding processes, and that's something that we're working through at the moment. So the platform team that I look after provides Kubernetes, but we have lots of other services that we provide to the customer transparently via Backstage, and they're actually looked after by teams that are better than us, so experts in their field. So we're doing a database as a service model, which is looked after by our lovely data services team, but you, the customer, when you come to Backstage, you don't really need to know or care who looks after it. You've come to the single entry point. You have declarative config for your namespace where you tell us what kind of namespace that you want, like what's your egress and your ingress. You tell us what kind of database flavor that you want and what your size requirements are, and then our pipeline takes care of that in the background. And Backstage is a beautiful visualization that brings that all together.
And just one quick thing to add to that. So just like with any architecture stack, you can choose to put logic in different layers, right? So it's up to you how much logic you want in your portal layer, and Backstage can handle some complex logic. But just in our experience working with customers, the more you push into your GitOps pipelines, the more you automate through IAC, the more flexibility you have over time.
Okay, thank you.
Hey, Rachael, Jim, awesome presentation. Love the demo. I think this was a pretty novel use of Kyverno, and I wanted to ask what that network policy looked like on the backside. So you gave it a really simple name, allow DNS traffic or something like that. Does that just look like a regular network policy we've seen 1,000 times before?
It does, right? So what happened underneath the covers is Kyverno actually generated a network policy based on that label. So based on any trigger that you wish, here we use labels to trigger the generation of a new resource. And it cleans up too. So if you remove that label, it would delete that policy for you.
Does it actively maintain that network policy? So let's
Yes.
say you add something to the policy itself later.
That's correct. So there is, there's two ways you could clone resources from a common set, and this is very routinely done with Kyverno and secrets. As another example, like every namespace may need registry secrets. So you can clone those, but if you update your secret at the single source, it will propagate to all of the clones.
Awesome.
Just,
Jim's going to need that GitHub repo.
I was just going to add to that, actually, from an enterprise perspective, what's been really useful in some of the conversations that Jim and I have had that's echoed other customers' usage is that we have two tiers. So the platform wants to have default standards, particularly for security, that we bake in using Kyverno. But that's not to say that we don't limit customization from the workload teams. So we have the network policies that are enforced by standard, but there is some flexibility that if your workload has a particular use case, you can add your own network policy. And what Kyverno allows us to do is have that two-tiering, where I can set what can never be overruled, one policy to rule them all, versus which policies can be overruled by the workload if it's appropriate.
Yeah, really awesome. Thanks, guys.
I think we're good. Oh, we might have one more there.
Do you use Crossplane for your developers to abstract?
We do not
services?
currently use Crossplane, no.
All right, thank you.